Hey guys, it's Mr. Dugal, and today we're going to talk about the Pythagorean Theorem. And the Pythagorean Theorem says that when we add the squares of two legs of a triangle, that it equals exactly the square of the hypotenuse of a triangle. So let's go through that. Let's define our side lengths, and then we'll do a couple examples of what we're talking about. So first of all, the first word, hypotenuse. Hypotenuse has to do with the side opposite of the right angle. So side opposite of right angle. In this case, if we find our right angle and go opposite of it, we see that directly opposite of our right angle is side C. The legs are the sides adjacent to the right angle. So adjacent meaning next to. So in that case, next to is A and next to is B. So we said that our two legs, the sum of our two legs squared equals the sum of our hypotenuse squared. And this is the formula for Pythagorean theorem. So Pythagorean theorem again says that the sum of the two legs squared equals the hypotenuse squared. And it only again works for a right triangle. So let's go ahead and use a few numbers and we'll go from there. So in this case, we have in place of A and B, we have 3 and 4, and in place of C, we have 5. So for example, we have 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, and 5 squared is 25. This is true, so therefore we have a right triangle. This is an example of the Pythagorean theorem in work. They might also give us questions where we have to find one of the side lengths. In this case, again, we have our two legs to be 5 squared and 12 squared. And we're going to set it equal to x squared because we know that our two legs squared, the sum of the two legs squared equals our hypotenuse squared. So here we have 5 squared is 25, 12 squared is 144, and it equals x squared. 144 plus 25 equals 169. Which is equal to x squared. So something times itself equals 169. In order to find that, we take the square root of 169, and we find that x equals 13. So there might be problems where they have us look for one of the side lengths. In this case, we were looking for the hypotenuse. There might also be a problem where we're looking for one of the legs. So in this case, we have 6 squared as one of the legs. The other leg is y, so y squared. And finally, our hypotenuse squared is 10, so 10 squared. When I simplify this, I get 36. 6 squared is 36, plus y squared equals 100. I now have to isolate the variable, so I do the inverse operation. I'm going to subtract 36, subtract 36. I'm left with y squared equals 64. So something times itself equals 64. In order to find that, I take the square root of each side, and the square root of 64 is 8, so y equals 8. Those are examples of the Pythagorean theorem in motion. And because of the Pythagorean theorem, we also have a couple of other things that we know to be true in relation to the side lengths. And basically, we now know that not only does a squared plus b squared equal c squared, but we also know that if c is bigger than the sum of a squared and b squared, we have an obtuse triangle. So for example, if the side lengths are 4, 6, and 9, we do have a triangle. Remember, we don't have a triangle at all if the two smallest side lengths are less than or equal to the biggest side length. In this case, the two smallest side lengths are bigger than the largest side length. So when I find the squares, I have 4 squared, 6 squared, and 9 squared. 4 squared is 16, 6 squared is 36, and 9 squared is 81. And basically, I know that 52 is less than 81, so this must be an obtuse triangle. Remember, the bigger the side length we have, the larger the angle that we have within a triangle. So if I have a super big side length, 9 is substantially bigger than either 4 or 6. This means that I likely have an obtuse triangle. And I can actually do the math to figure out if the two smallest sides squared, the sum of the two smallest sides squared, are smaller than the largest side squared, that means I have an obtuse triangle. Similarly, if I have 4, 5, and 6, for example, as my side lengths of a triangle, 4 squared plus 5 squared compared to 6 squared, I know that 4 squared is 16, 5 squared is 25 compared to 36. 16 plus 25 is 41, therefore 41 is larger than 36. This means that I have an acute triangle. So when the sum of the square of the two smallest side lengths is larger than the largest side length squared, I have an acute triangle. So those are different ways that Pythagorean theorem can be applied. And the heart of the Pythagorean theorem says that a squared plus b squared equals c squared, meaning that the sum of the squares of the two legs equals the hypotenuse squared. Hopefully this sets you up for a strong foundation with Pythagorean theorem. Thanks so much for watching.